Hello everyone. The title of this video is Use the Discriminant to Predict the Number of Real Solutions of a Quadratic Equation. In this video, I'm going to be completing some exercises taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.3, titled Solve Quadratic Equations Using the Quadratic Formula. And I'm under the heading, Use the Discriminant to Predict the Number of Real Solutions of a Quadratic Equation. I'm only going to be working on the even numbered exercises, right? So exercise 146 and 148 with all their parts in this video. You may notice that the odd numbered exercises have links on them, and you can click on those and see the solutions to those exercises. But the even ones do not. Right, so I'm going to be working on the even ones. Also, I will have timestamps for each exercise in the description of the video below. You'll see example 1's timestamp, that'll be for number 146, and example 2 will be for 148. And one thing I request of you while watching this is that when I start a new part of a question, pause the video and try to do it yourself first before you watch me do it. Because if you're just watching me do these questions and not practicing yourself, chances are you're not learning all that much. Alright, so first exercise is 146, which I have written out here. And we are just simply asked to determine the number of real solutions for each quadratic equation. Now, to just notice they don't say find the solutions. They just want to know how many real solutions will the quadratic equation have. So this is going to involve something called the discriminant discriminant of a quadratic equation. So here's what the discriminant of a quadratic equation is. Given equation ax squared plus bx plus c equals 0 with a non-zero, right, the solutions are the following. X equals, the opposite of b plus or minus the square root of b squared minus 4ac, and then all that divided by 2a. Now you may recognize this, right? This is called the quadratic formula. Pardon me. So if you have an equation in this form only, right, the equation has to be in this form, where you have a quadratic term plus a linear term plus a constant term equal to 0. If your equation is in this form, you can jump straight to the solutions. Where a, just plug in a, b, and c, where a is the quadratic coefficient, b is the linear coefficient, c is the constant, into this formula and simplify, and you'll get your two solutions, or one solution, whatever the number of solutions are. Now, we're not asked to do all of this time. All we're asked to figure out is, of the solutions of this equation, how many of them are real and how many of them have an imaginary part, have an imaginary number in them. And that will all be determined by the radicand of this square root. The expression under the square root, right, the expression b squared minus 4ac, that's called the discriminant of this equation ax squared plus bx plus c equals 0. Is called the discriminant of the equation. It helps us to discriminate among what kinds of solutions the equation will have. So here are the cases. 1. If the discriminant, right, if b squared minus 4ac is a positive number, right, if it's greater than 0, then you'll have, the square root of a positive number here in the quadratic formula. And remember, the square root of a positive number is real. And so you'll have two real solutions, negative b plus the square root of the discriminant divided by 2a, and negative b minus the square root of the discriminant divided by 2a. So if the discriminant, right, b squared minus 4ac is positive, the equation has two real number solutions. Two real solutions. Okay, that's case 1. Case 2. If this discriminant, right, if b squared minus 4ac, what if it's equal to 0? Well, then that square root would disappear, right? If b squared minus 4ac is 0, then this is gone, and the only solution to the equation would be x equals negative b over 2a. So if b squared minus 4ac, if the discriminant is equal to 0, the equation has just one real solution, right? X equals negative b over 2a. Has one real solution. All right, then the third case is, well, what if that square root is the square root of a negative number? Right? If the discriminant, right, b squared minus 4ac, what if that's less than 0? What if it's negative? Well, then, in the quadratic formula, when you're finding the solutions, you'll be taking the square root of a negative number. And remember, the square root of a negative number is not real. It's imaginary. So you'd have negative b plus some imaginary number divided by 2a, and negative b minus some imaginary number divided by 2a. So in that case, the equation has two complex solutions with an imaginary part. But in most books, they'll just say two complex solutions, even though real numbers are also complex. But, usually when people say complex, though, they think, oh, it's got to have an imaginary number in it. So two complex solutions with an imaginary part. Right. Now, because these solutions have an imaginary part to them, that means that the equation has no real solutions. Right? No solutions that are strictly real numbers. Right? They're going to have some sort of imaginary, right? Some sort of square root of a negative number involved. Alright, so this is key. This is all we're doing. We're taking this value here. Now the equation has to be in this form. It has to look like this, ax squared, everything on one side, 0 on the other. With the quadratic, linear, and constant term like this. It has to look like this in order for us to say all these things. So in these exercises, we're given an equation. We're going to calculate the discriminant, this b squared minus 4ac, right, the expression underneath the radical in the quadratic formula. If it's positive, we know that the equation has two real number solutions. If it's 0, we'll know that the equation has just one real number solution. And if it's negative, the equation has no real number solutions. It'll have two complex solutions, with an imaginary part, or just two complex solutions. Okay, fantastic. Now, let's get into the first question. All right. So going back to the exercise, right, example 1, which is exercise 146 from the text. And we're asked to determine the number of real solutions. So part A, this equation is in the form that I want. It's a quadratic term plus a linear term plus a constant term equals 0. So it's in the form that I want, so I'm going to identify now the A, B, and C, right? A is the quadratic coefficient, 9. B is the linear coefficient, negative 15, right? Don't forget the negative. And C is the constant term, positive 25. So now I just find this discriminant. Right? I'll write it out again. Discriminant. The discriminant is that expression, under the square root in the quadratic formula. That's b squared minus 4ac. So negative 15, I'm just plugging in these values now. Negative 15, that's squared, minus 4 times a, right, times 9, times c is 25. And then we simplify this, and if it's positive, right, one more time, if it's positive, the equation will have two real number solutions. If it's 0, the equation will have one real number solution, just negative b over 2a. And if it's negative, the equation will have no real solutions. It'll have two complex solutions, with an imaginary number in it. All right, 15 squared is, negative 15 squared is positive 225. And then we have, minus 900. 4 times 25 is 100 times 9 minus 900. And this is definitely negative, right? This would be negative 675, right? Which is, less than 0. It's negative. A negative discriminant. So that means that this equation, that means the equation has no real solutions, right? Because you'd be taking the square root of a negative number. You'd have two solutions with an imaginary number in it. But there are no real solutions, right? It would have two complex solutions, or two complex solutions with an imaginary part. I'll just say with an imaginary. But that's it. All right? That's all we're saying. That's all they want from us, is just state how many, what kind of solutions will this equation have. They're not actually asking us to find the solutions. Right? Now you can go and find the solutions, right? Use the quadratic formula and find the solutions, and you'll see, you're going to have two solutions that have an imaginary part to them. All right, part B is the same thing. All we're asked is, how many real solutions does this quadratic equation have? And that's it. We are not asked to find the solutions. We're just asked to say, how many real solutions are there? Now, this equation is in the form that I want, right? It's quadratic plus linear plus constant equals 0. So now I can identify the a, b, and c, right? A is the quadratic coefficient, 100. B is the linear coefficient, 60. And c is the constant term, 9. And I'm going to do the discriminant, right? I'll keep writing it out. You know, actually, I'll write out the word this time, but I'm just going to call it capital D, for discriminant. And we have D equals, b squared minus 4ac, that expression that's underneath the square root symbol in the quadratic formula. So we have 60 squared minus 4 times 100 times 9. This is 3600 minus 3600 again. This is equal to 0. When the discriminant is 0, the equation is going to have one and only one real solution. And it would be negative b over 2a, so negative 60 over 200, whatever that is, right? But the equation in this case has exactly one, or just one, real solution. And that's all we're asked to say, right? Don't find the solutions, right? You can if you want, but you'll notice that there's only going to be one solution, one real solution to this equation. Alright, and same thing for part C. The equation is already the way I want it. Quadratic plus linear plus constant equals 0. So I'm going to identify the coefficients now, right? A is 5, B is 7, and C is negative 10, right? Don't forget the negatives. The discriminant, which I've been calling, capital D now, is again b squared minus 4ac. So 7 squared minus 4 times 5 times negative 10. This is going to be a positive number. Alright, this is 49 plus 200. Alright. So 249. This is greater than 0. This is a positive discriminant. When you use the quadratic formula to find the solutions, you'll be taking the square root of a positive number. Those are real. And if the discriminant is positive, then the equation has two real solutions. And that's it, right? We're not asked to find the solutions. Just say how many real solutions, what kinds of solutions will the equation have. Great. Alright, and the next question, same thing. It's the same stuff, right? I'm doing the same thing for all these. And the nice thing is, for these exercises, the equation is already written in the way I want it. Quadratic term plus linear term plus constant term equals 0. Just please know that if it's not in this form, you have to get it in this form in order to talk about the discriminant and the quadratic formula and any of that stuff. Right? Please understand that. Alright, so number 2, which is exercise 148 from the text. Part A. So it's in the form that I want. So I'll identify the coefficients, right? A is the quadratic coefficient, 25. B is 10, the linear coefficient, and C is the constant, 1. Capital D for the discriminant, right? The discriminant of this equation is b squared minus 4ac. So 10 squared minus 4 times 25 times 1. That's 100 minus 100, which is 0. And when the discriminant is 0, the equation's going to have exactly one real solution, and that's it. So this equation has one real solution. And that is all we're asked to say. Great. All right, part B. Same thing, it's already in the form that I want. Again, if it's not in that form, get it in that form, manipulate, move things around. So I'll identify the coefficients, right? A is the quadratic, positive 7. B is the linear, negative 3. C is the constant, negative 6. Capital D for the discriminant, pardon me, it's b squared minus 4ac. So negative 3 squared minus 4 times 7 times negative 6. This will be positive. Right, this is 9, and then we have negative times negative here, which will be positive, and then times positive 7. But that's negative 28 times negative 6. That would be 168. Right? 4 times 42, 168. Putting together, you got 177 for the discriminant, which is positive. Pardon me. And when the discriminant is positive, you'll be taking the square root of positive numbers in the quadratic formula. Your solutions are both strictly real numbers. Right, so the equation that we were given here for part B, this equation has two real solutions. And that's it. Right? We aren't asked to find the solutions, just say how many real solutions, what kinds of solutions will the equation have. So hopefully you're seeing that this is pretty simple stuff, especially if the equation is already given in the form that we want. So see again, linear plus quadratic term plus linear term plus constant term equals 0. It's already in the form that I wish for. I'll just identify the coefficients, right? A equals positive 7, B equals positive 2, and C equals positive 8. The value of the discriminant, right, that expression underneath the square root in the quadratic formula, b squared minus 4ac, is the following. We have 2 squared minus 4 times 7 times 8. So this is 4 minus, and then 4 times 56 be 224. This is negative 220. Right. Negative 220. Okay, definitely negative, right? Less than 0. And when you have a negative discriminant, right, that means you're taking the square root of a negative number in the quadratic formula when trying to find the solutions of this equation. And the square root of a negative number is imaginary, right? Non-real. So the equation would have no real solutions. And another way to say that would be it has two complex solutions with an imaginary part. I'll just say complex solutions with imaginary. And I know in this text, I believe they just say, two complex solutions if there are no real solutions. Okay. Great. Yeah, so pretty simple stuff there in my opinion. Hoping that watching me go through these 6 examples here for these 2 questions, 3 parts each, hoping that watching me do these here help you in some way when you're asked to determine the number and type of solutions of a quadratic equation using the discriminant on your own. And thank you very much for watching.